John.
Wait, what are we doing?
Jan, you have to introduce us.
Hello, I'm David Murphy here. I'm a junior, going to be a senior, yeah. And this is the introduction to the AP Stat Session 3 podcast. You already know what it is. Here's my co-host here.
Jason and Torrance.
Yeah, and it's going to be litty, as Coach Jay would say. Yeah.
Let's go. There we go. Nicely done. Nicely done.
Wait, are you stopping?
No, that's it. I'm going to start it.
You're gonna start?
Unless you want to join with us.
I was going to talk to you, but it's okay.
It's kind of awkward a little bit. Yeah.
Y'all enjoy your podcast. I'll come back and talk to you.
You'll come. Give me 25.
All right, yeah.
25. Hey, this is live, y'all. I don't mess around.
Oh, this is live?
It's absolutely live.
Wait, who's on it?
Well, people could be on here, but they're not. Only people from Sweden.
Are you serious?
Yeah, got Sweden followers.
Who is this for? Who is this statistics thing from?
It's for statistics. I get hired out for this stuff.
Oh, I thought this was for like JC kids. When was the stat final? Wasn't it today?
Yeah, it is today. Yeah, it is. But we are in summer session 2018-2019 session. So without further ado, we like live stuff. This is good. We don't make this stuff up. Let's get it rolling. All right, so a couple things. Again, session 3. This is our last session. Hopefully this isn't too long, just a little bit to get our whet our appetite a little bit for some statistics info. Special thanks to Mason, Torrance, and the Murph Daddy for coming in, giving us some help today. And let's talk about it. So first thing we're going to do is we're going to talk about some center stuff. We talked about the mean already. I don't think that I have to talk too much about mean other than the fact that you know that you would add all the observations together and then divided by n. A couple things about this. N refers to the total samples that I have. So let's say for some reason that we're trying to average the amount of points Coach Jay scored in high school, which was a ton, but just saying. If he had 20 games, the 20 games would be represented of the N, whereas the top would be all of the points that he had within that season to average that out. Couple of things to also note, mean refers to X bar. So if I'm finding the average of that, let's say that I score 20.6 points per game, I would then say 20.6 is equal to X bar. Just the same thing. It's just gang sign for mean. That's how we would represent that there, okay? Also, a couple other notations. X sub 1, that just means that was what I got in my first game. X sub 2 is what I got on my second game, and so on and so forth. A couple other things that you need to note as well. If you see this sigma thing, that just means the sum of. So this is the same thing. It's just mean. N is the total amount of games that I played in. The sigma would be the sum of all of those games that were there. So sigma is just a fancy word that means to add them all together. There's also a difference between population mean and sample mean in terms of the notation that's there. Just keep that in the back of your mind. We're going to look at that in just a little bit later in sections to come. Median, we already talked about median. We represent median with capital M. It's a little bit easier. We know that it's the number that's in the middle, so it's the observation in the middle. So if I were to take a distribution, let's say I had a dot plot of all of my games, right? I would label the bottom, and I would make sure that I would have each of these tick marks correspond with the scale that was there, maybe 5, 10, 15, 20. The middle value within that distribution we call our median. So we arrange them all from lowest to highest, and we find the number that is in the middle or the center of it, okay? If the observation is even and you have two numbers that are in the middle, you would then simply average those two numbers together, okay? And so, again, that's how we would do that there. Let me give you an example of this. Let's say that Coach Jay pulls a random sample of 20 students. Remember the notation? That would mean that N equals 20. 20 total students at GAC to see how many texts on average they send within a given school day, okay? Like I know that, for instance, each of these pieces of data would represent one student. So we know that David Murphy, he doesn't ever listen to rules, so he would be more towards 85. Whereas maybe someone who would be a little bit better would be more towards the 5 side. But regardless, if I found the mean of this, or the x of it, we would take all of these and add them together, dividing it by the sample total of 20 to get 31.25, and then make sure context minutes there. Within the stem and leaf plot, we recognize that what we did earlier was that if I looked at this from least to greatest, we would have more of a skewed right data that was here. Again, make sure that over on this side, we would represent what 4-5 means in the context of this. So 4-5 would represent 45 texts that a student would send within a given school day. We recognize, too, that the median of this value would be, we would just kind of go, so right here, the least to greatest, we just kind of keep rolling here through until we get to the 2 middle values, which is 2, 0, and 2, 5. So once we have 2, if it's even, now if it was just 1, we just take that value. But 20 plus 25, we divide by 2 to get 22.5 minutes as the median. Again, you'll notice the shape of this. What would this be? And you'd be right at home. It'd be skewed right because it's pulled to the right of that value. So it'd be pulled right, so we say skewed right. Now, this next part is extremely, extremely important. The question that we want to ask is, out of a median and mean, which is affected more by outliers? Okay, big idea, okay? Golden nugget right here. This is a golden nugget. You got to know this, okay? So let's say that I've got a distribution, and it looks like this. It's skewed to the right, so I've got outliers out here. These are like outliers right here, okay? Outliers. The question is what would be pulled by outliers? So we've got our distribution. Again, we've got our scale. After we scale it, right, we got this here, okay? And we put context down below. Make sure we write those numbers in. When I notice this, what would be affected more by the outliers? Well, a couple of things that we got to understand. If we had a mean and median related to a roughly symmetric graph, so let's say we've got, instead of a skewed graph, we have something that's approximately normal or approximately symmetric. And as we look at this, we have our data here that's approximately normal. Where would the mean and median be? Well, if it's approximately normal, we would expect the mean, X bar, and the median, capital M, to be approximately the same, or we would say it's close together, okay? However, if we have a skewed data, let's say skewed to the right side here. So we have skewed right here. In this instance, we would say that we'd ask the question, what would happen with the mean and median? Okay. Well, what happens is the tail pulls the mean. Think about it. If I have more outliers, what would affect more, the average, or would it affect more the middle value? The question, or the answer to that, is the skewed distribution would pull more of the mean. So the tail pulls the mean. So if I were to have a skewed right data, I would expect my median to be more towards this left side, where the mean would be pulled more towards my tail side. So the tail would be more towards, or the mean would pull more towards my tail. So X bar would be over towards the right more than my median, okay? So that's how we would represent that there. So we would say that the median is resistant to outliers, okay? It's a resistant measurement. So if I have an outlier, it will not pull my median, but it will pull my mean. Again, the reason why is when I have an outlier, it affects more of my average rather than affecting the middle value. The middle value is not affected by an outlier because, again, it's just the middle. It's not the average of it. So if Coach J, here's a good example of this. If Coach J, let's say that this is the points per game senior year Coach J. All right, here we go. If Coach J were to, let's say, represent this as 20, and he has a dot plot that looks like this, right? And we'll say this is 15. Maybe he has a couple in between. 15 goes here, right? And we'll say that 10, he had one, maybe two bad games. And 25, he had 1, 2 here, 3 here. And let's say 30, he had a couple here, right? 35, he had 1. But let's say one game he went off for 50 or 45, we'll say. Make it right there, okay? This right here would be an outlier. Therefore, as I look at this distribution, skewed right, moderately skewed right, we would expect the median to be more towards this side, whereas the mean would be pulled more by that outlier. It would be more towards the right. So X bar would be more towards the right than my median would be, okay? And so again, that would be more what would happen in terms of the relationship between mean and the median, okay? Okay, so big important idea. When do we use mean and median when describing center, okay? What we would say is that since the median is resistant to outliers, okay, resistant to outliers, if it is approximately normal, we use the center mean, okay? We use mean when it's approximately normal. When it is skewed to the right side, we traditionally use the median as center. That's a huge idea. Star that, highlight that, big idea. So if you end up comparing two distributions and you talk about the center, if it's approximately normal or symmetric, we use mean. And if it is skewed one way or another, we use median because it's resistant to outliers. Okay. All right, check this out real quick. This right here is something that's really good. Couple questions here. I think I didn't get the answers here, but check them out. See if you can just answer them in your head and see if you can get that down there. And we'll continue. So get that down and we'll rock and roll. Let's go to the next one here. This idea of spread. We have two ideas of spread that we're going to wrap up here as we finalize our stuff today. We're going to talk about spread related to IQR, interquartile range, and we're also going to talk about standard deviation. A measure of center alone can sometimes be misleading. So we talk about the spreading out of data, how tight or how far the data is from the rest of the data that's there. Now, when we talk about this, that's why when we give measurements, we don't just talk about center. We also talk about how spread out the data would be, or what we call variability of that graph would be. Big word too. We talked about that in session 2. So as we talk about variability, we have one idea called IQR. Now to calculate the quartiles, first we're going to arrange them from least to greatest and find the median of that data, okay? Then from that median, we're going to find the first quartile by finding the median of the first 50% of the data, and then finding the median of the second 50% of the data, and we'll call those things Q1 and Q3. You'll see that how we do that in a second. We then subtract Q3 minus Q1, very similar to range, except now we're talking in terms of the 75th percent, like the 75th percentile and the 25th percentile, okay? All right, so take a look at this. This is the data of the travel times for work for 20 randomly selected New Yorkers. Remember, little n refers to 20, our sample size. Now, to find the median, we would simply find, go, right, from one to the other, 1, 1, and we just find literally the middle data. And as we look at that, we get the middle values of 20 and 25. We average those together to get a median of 22.5. And again, this would be our middle piece of data. Okay, so our middle data right there. So what this means is that 50% of the data is to the left of 22.5, while 50% of the data is to the right of 22.5. To find now on the left side, the first 50% here, we want to find what the median of that first 50% is, and we label that as Q1, okay? So the Q1, and we label that as almost like the 25th percentile. So to do that, we're then going to take from 20 to 5 and simply do the same. So we're trying to find the middle value. We do that for each of them until we can finally come to the middle of 15 and 15 because there's no middle value here. So we're going to average that together to get 15 as the 25th percentile. We can represent the fact that the number between 15 and all the way to the left represents 25% of the data, where from 15 to 22.5 is the second 25% of the data. And then the third we can find by finding now out of the second 50%, the median there. So we do that and get to 40 and 45 to get a median of 42.5. We label that Q3, which represents the 75th percentile. So if I were to ask you, what is the middle 50% of the data fall between? We would say between 15 and 42.5, which would be a range of 42.5 minus 15, which we label IQR, and that would be a grand total of 27.5 minutes that was there. So that's how we find IQR, is we're really taking the middle 50% of the data and we label that as IQR. So if I said, what is the percentage that is between 5 and 42.5 minutes, we'd say 75% of the data, because we have 25 here, let me label that, 25 here, 25 here, 25 here, which is 75%. So it's like I put it in 4 quarters, right? 4 quarters of a game. It's kind of how I label the data that's there. And that's one way to talk about spread, is labeling it as IQR, okay? All right. The quartiles in the IQR are resistant. They are not affected by a few extreme observations. So again, just like with median, it is not affected by an outlier because it's just the middle value. If I had a value that was, let's say that instead of 85, I put 1,000, the IQR would not change because, again, you're just finding the middle value. Whereas if I found the average of this, remember that that would be affected because 1,000 would be impacted by is not are resistant. Okay, they are resistant to outliers. They're not affected by outliers there. Okay. All right, let's talk about an outlier here. What is an outlier? An outlier is something that follows either one of 2 definitions. It's either Q1 minus 1.5 times IQR or Q3 plus 1.5 times IQR. So if I were to take the example of the New York travel time that we labeled earlier, and I was to see, does this have an outlier, we would take the Q1 from the previous example, okay? I want to kind of show this to you here because you've got all this information here. To find the outlier, I would do 1.5 times Q1 minus, that's right. Okay, so Q1 minus 1.5 times IQR. And then over here, the outlier range would be Q3 plus 1.5 times IQR. Now, we've already found IQR, so this makes it easy. Q3 would be 42.5 plus 1.5 times 27.5. Okay? Over here, this would be 15 minus 1.5 times 27.5. Now, once I get these 2 values, they've already calculated for me, negative 26.25 and 83.75. Negative 26.25, 83.75. These are what I call my boundaries within my outlier. So if there's anything that is to the left of negative 26.25, it's an outlier. And anything that's greater than 83.75 is an outlier. So based upon the data that I've put here, 85 is the only data that falls to the right of my 83.75. So notice again, the Q1 or Q3 is the one that's to the right boundary, and the Q1, I subtract 1.5 times IQR. that's my left side boundary. So any values that are to the left, we call that an outlier over here. Anything to the right, in this case we had 85, we would say 85 is an outlier within my distribution that's there, okay? In this case, we used our stem and leaf plot. Okay, boom, 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 got that? Like it? All right, again, make sure you get that down. 1.5 IQR rule for outliers. This is something that you need to know. This is not on your formula sheet, okay? Not on formula sheet. Okay, I got to know that one. All right. Okay, 5-number summary. We are getting it on. All right, keep it going with me. Getting there. Let's keep it rolling. 5-number summary. We come up with a couple things. We need to know 5 different values: median, Q1, Q3, maximum, and minimum. Maximum and minimum are just simply the highest and lowest value. Okay. And that's how we write it. Minimum, Q1, median, Q3, maximum. We call that a 5-number summary, okay? And it helps us to write out what the distribution would see. Now, a box and whisker plot is our final quantitative piece of data that allows us to be able to write it out, the distribution, be able to show a graph of the distribution. And in doing so, we draw and label a number line. We draw a central box from Q1 to Q3. We note the median, and then we extend the whiskers, extending out to outliers, outliers being the points that are there. So this is the one we just stated, where 85 was an outlier. That's one thing important to note. So anytime we have an outlier, we're going to highlight that. And just instead of including that within my distribution, it's going to be chilling by itself. So we're going to put a little 85 right there, okay? That was the amount of points Coach Jay scored. I scored that my junior year, 85. Okay, so, all right. So with that being said, we look and see what is the 5-number summary. So we know that the maximum is 85, but because of the IQR rule, the new value that's represented as the whisker that it comes to is 65. So we're going to put a boundary there. Again, outliers here. Otherwise, if this was not an outlier, it would extend right here. The low value, my minimum, would be 5, and we're going to put something that's like a boundary there, okay? The median, 22.5, we've already said that. 22.5 would be here. Q1 would be 15. We're going to put that there, okay? 42.5, we're going to put that there, okay? And so because of the Q1 to Q3 that's there, we're going to include a box between the middle 50% of the data, between Q1, Q3, and then the median will have one line that's right here, okay? So this is the middle 50% of the data here, and then to include the whiskers, this is our box right here. The whiskers extend to the minimum, and then from Q3 to the maximum. And then again, remember this outlier will just be chilling by itself, okay? It's called a box and whisker plot. Make sure also you label it as well, okay? There's going to be one on the test like that. Make sure you label the variable that's there. In this case, the travel time, okay? So make sure you know how to do that box and whisker plot on that one. Make sure you also know how to compare the travel times, or compare them. So if we had one between New York, right here, and North Carolina right here, what we could say is comparing the same thing. So shape, what would be the shape here? Both are, if the median's here, that means the majority's here, okay? So this would, again, the way it's viewed is kind of weird, but this would be more right skewed because as we look at it, the lower end's here. So you'd have to like flip it up right here. So the New York would look like that. So would the North Carolina. So that's why in this case, we would say that they're both right skewed. The center, it looks like it's just a little bit longer for New York compared to North Carolina. Not much though, as far as the medians go. The spread of the data, it looks like the IQR of North Carolina would be smaller than New York as far as the IQR that's there. And And then the outliers, we notice that there is an outlier for New York that's at approximately 85, and there are none at North Carolina. And as I compare them, make sure that you also state something about the context of comparing travel time to work in minutes from North Carolina to New York if I were to write that on an FRQ. Context is king, okay? Make sure you include context. That is very, very, very important. Okay, so there's one too. If you want to look at that one's a really good one, showing similarities and differences between. Here's the answer, and that is straight from an FRQ as well. So check that out. Check that out, and we'll continue. Okay, so we got the technology stuff. Boom. Hit that. Okay, so I'm going to get this calculator up. I think I'm going to hit on that later on. Boom, boom, boom. Okay, I'm going to hit the calculator last, okay? So we're going to come to that in just a second. Last thing was standard deviation related to spread. So we had IQR. Now we're going to have standard deviation. Standard deviation is not resistant to outliers, okay? So outliers do affect standard deviation. So just so you know, standard deviation is traditionally good. This is when it is symmetric, traditionally. So when it's symmetric, we describe it with mean and standard deviation. When it is skewed, we describe it with a range, specifically IQR. And then we also describe it with a median for center. So these go together where these go together. Standard deviation, huge definition. It's the average distance each value is from the mean. Get that down. Average distance, each value is from the mean. Big idea. So if I were to find what the mean is, let's say in this example, the mean would be what did we say? 5. 5 is the mean. If the mean is here, then what I would do is we calculate the mean, we label that as 5. Then we calculate each deviation or distance each value is from its mean. So once I get this here, I could take 8, so this dot, the deviation would be 8 minus 5, which would be 3. This would be 9 minus 5, which would be 4. Right? And I take all of those deviations that's there. All right, so I'll kind of go, so we'll get all of the deviations. I kind of back up here, okay? So if I put 1 in, the deviation of that would be -4, because 1 minus 5. This would be -1, 2, -1, -1, -1, 0, 2, 3, and 4. We're then going to take the deviation and square it. So this would be column 3, which would be 16, 4, 1, 1, 1, 0, 4, 9, and 16. Okay. So this is the deviation squared right down below. Okay. So the reason why we have to square it is because we're only finding the average distance each value is from the mean. So if some are negative and some are positive, there's no way for us to really calculate that. So what we're going to do now is continue and ask us, if we add all of the deviations from the mean, what do we get? Well, you would get, if I added all of these up, that would get 0, which that doesn't really tell me a whole lot. So that's why in this case, does this tell us anything about the data? Because if we get 0, that does not, right? So what could we do to the deviations to get a better idea? Well, we just did it. We square it to make sure that we get all positive values that's there. So once I do that, I can then average. Let's see here. We take this deviations, and what we can do is just average this together. So when we average it together, we would take the sum of the deviation squared, right? That's just summing or adding all these up. And then what we're going to do is we're going to take this, and then we're going to divide by which is our sample size minus. We'll talk about that a little bit later. Really, we're referring to the fact that it's called variance within this. And so standard deviation and variance are very much one and the same. So if I averaged all of them together, I would get 52. And then once I divided by 8, it would be about 6.5. But we called that variance, okay? So once I add up all of the average squared deviations, we call that variance. And to go from variance to standard deviation, we simply square root it. So I always think that standard deviation is the lower value and variance is the higher value. You always square the standard deviation to get to our variance, okay? Square the standard deviation to get to variance. Again, the average distance each value is from the mean. Now, what's cool about this is you actually do not have to solve this, okay? There's an easier way to solve this without having to do all of it, and we'll show that here in a second. So we've got the deviation. We square the deviation, right? We found the sum of it. We average those together. We find variance. We square root the variance. Get the standard deviation. So let's see here. This will be our last thing. And then I want to show you on the calculator here. If I was to find what the formula is, I would take each value, subtract it from the mean, square it, add up all those values, divide by n-1, and you'd get your answer. The good news is you don't actually have to do that. You could actually go straight to your calculator. I'm going to show you how to do this, and this will be our last thing here. Let's see here. There you are. All right, so let's say that in my, you can go to your list by going to Stat right here, and you go to Edit, okay? And let's press Clear down. So we're just going to put in L1 what we just found. This was straight from that specific one there. So 1, 3, 4, 4, 4, 5, 7, 8, 9. If I was to find the standard deviation, go to Stat right here. So again, Stat Edit goes right here to L1. Put your data in the list. If you want to clear it, go up here, press Clear, and then just press down and it clears it for you. But then if I want to calculate everything, go to Calculate, Stat Calculate, one variable statistics, L1, and you'll put nothing in for frequency list, so just L1 there. Press Enter and Enter, so you press Calculate, and it gives it to you. So you have your mean here, right? That's X bar. S of X is the standard deviation of my sample, okay? Right here, we'll talk over that. Here's the standard deviation of my population. We'll talk over that as well. What you need to be concerned with now is we're just going to say that 2.4 is sigma. We'll say that that is standard deviation. N is the sample size. That's how many pieces of data are there. Minimum's there. Q1's there. Median's there. Q3. You can find IQR by doing 7.5 minus 3.5. You've got your max. And you've got everything there. So you've got all of this stuff here. Again, be able to find it. So the big thing is standard deviation, average distance each value is away from the mean, and then being able to find it using your calculator. If you can exactly where we want you to be. All right. All righty. Hope you have a good one. That was session 3. That's the last one. I hope this was helpful in preparing you for AP statistics. If you got any question, text me, email me. I'll be throughout the summer helping you along. We'll see y'all.